facing blue. We are going to have Gino Calderon. He's a Peruvian engineer, currently working in Brazil, in Vale. So he came here to visit us for the Tailings conference here in Brisbane. So I think to stay here for a couple of weeks and invite him to make this presentation about his experience in Brazil. As you may know, always been following the disaster in Brazil, regulations there, as obviously demanding a new approach in terms of how to manage the risk in tailings. And in that approach, of course, they are trying to, obviously they are implementing now, obviously, the Decommissioning of tailings facility as a part of the mandatory statement in the regulations. So there is no much of those activities around the world. And obviously it's a good opportunity for us to hear from first hand, and Gino can tell us how they are doing there. So I think the presentation today is challenge and opportunities in the tailings dam decommissioning in Brazil. So in order to introduce Gino, is a specialist geotechnical engineer at Vale. He's a bachelor in engineering from the Jorge Basadre National University in Peru. And he did a PhD in the Pontifical Catholic University at Rio de Janeiro in Brazil. So prior to joining Vale in 2020, he used to work as a professor in soil mechanics at Catholic University San Pablo and a geotechnical engineer at the Cerro Verde mine owned by Freeport-McMoRan in Arequipa, Peru. So we can give a thank you for Gino and please take this.
Welcome to my presentation. I am so happy you are coming here to hear about the decommissioning. My name is Gino Calderon. I am a geotechnical engineer. And the topic that I will present today is about the tailings dam decommissioning. Why is important this topic? Recently, we have some disasters in Brazil. For this reason, the regulation obligates the operator to decommission the dams, and so there are not so much information about that decommissioning. Recently, I was involved in these works, but unfortunately, I couldn't find enough information about that decommissioning, and so we are starting almost from zero. I would like to tell a disclaimer. I am not presenting on behalf of any mining company. This presentation represents my personal point of view about the topic. My interest is in sharing my experience and thoughts. The information presented is public and already published by different media. I'm convinced that geotechnical engineers can change the future by learning from the past. As an outline, I will talk about first about the background, the challenges. Next, I will talk about cases and final considerations. Let's talk about mining in Brazil. Brazil produced 410 million tons of iron ore in 2022. And is the second largest producer in the world. Also, Brazil produces copper, bauxite, gold, and other minerals. How has the Brazilian regulation changed over time? The Samarco TSF failure happened in 2015, and the issued the resolution FAM, which established that the operators should issue audits, declaration of stability, and action plans. The Brumadinho TSF failure happened in 2019, and as a response, the regulator issued the resolution for which established that upstream tailings are prohibited. In 2020, it was issued the GISTM, and finally, the last year, the Brazilian National Mining Agency issued the resolution ANM 95, which determines deadlines for decommissioning. What is the meaning of that? Dams should be decommissioned as soon as technically possible. What are the main Brazilian regulation statements? There are two, in my opinion. Is the decommissioning of upstream tailings dam, and the risk classification of them and determination of emergency levels. Level 1, level 2, and level 3. What are the decommissioning methods practiced in Brazil? There are three methods. The first one is the failure removal. And so the tailings are completely removed of the structure. It means to remove millions of tons of iron ore tailings. And there are two possibilities for these tailings. The tailings could be remaining or disposed in piles. Obviously, this method is the most expensive. Can you imagine to remove millions of tons of tailings? Also, we need to have license for remining or license for a space to build a pile. Second is the partial removal. Maybe it's the most frequently used technique in Brazil, and so it's necessary to have licensed area downstream. This technique consists of the removal of the tailings upstream and to put them downstream. And the third one is the buttress construction. When I talked to some colleagues from Australia, they told me, I can't imagine to remove all tailings. Why not you construct a buttress? Well, it's maybe the first option, but it's necessary to have licensed area downstream and borrow material. Sometimes there are some interference and it's not possible to build the batteries. For example, a river, a facility, or just to have licensed area downstream. However, the emergency levels defined by the Brazilian regulation, there are some criteria. This slide, I will show two of them. The first criteria is evaluating the factor of safety in draining condition. If the factor of safety is above 1.5, the structure is not at emergency level. If the factor of safety is between 1.3 and 1.5, the emergency level is 1. If the factor of safety is between 1.1 and 1.3, the level is 2. And below, the factor of safety is 1.1. The level is 3. And it's a high risk structure. The level 3 is dangerous. But there are some structures in that level. So what is the impact of that? What impact is related to being in a determined emergency level? And so the regulation obligates to operators to do something about that. If the structure is at level 1, the operator must stop the disposal of tailings. So stop the operations. If it is at level 2, the population limit downsing until 10 kilometers should be evacuated. If the structure is a high-risk structure, it means there is an imminent danger. The population limit downsing should be evacuated quickly. And so, why is the project development delayed? It's not easy to do that project. It's not a conventional project. On the upper part, we can see some steps to develop a conventional project for Tailings. The first step is to review of existing data, to perform a ground investigation, to do engineering project. After that, we can start the works in the field until to be completed. But for that decommissioning project, these steps are more delayed. It takes much more time. There are not enough data because the structures are old. The geotechnical investigation is hard to perform because there are restrictions for access. I will explain in the next slide why the project development is delayed. So we have some challenges. The first one is the review of existing data. The age of a tailings storage facility is in average 30 years. And so there are limited sources of information like geometry testing records. It's necessary to make an as-is to perform geotechnical investigation. As-is is a record of measurements and elements of an existing TSF at some point after construction has been completed. About the ground investigation, how to drill without drilling fluids. Drilling in dams is a hard task. There are evidences about fracturing on embankments by using drilling fluids. And so, drilling dam is risky. The practice in Brazil is to use the hollow auger. But the use of hollow auger has some technical difficulties. It's not easy. It's not possible sometimes to perform more than 15 meters on depth. Other challenge about ground investigation is how to perform CTU without operators in risky zones. If the structure is at emergency level above 2, the regulation doesn't permit to staying of workers on the field in that risky zone. So how can I investigate the ground? For that, a CPT remote is being used, and so the equipment is operated remotely, and the operator is at a safe zone, and the equipment is at a risky zone. So in this way, it's possible to investigate that zone. Another challenge is how to obtain material parameters of tailings, how to define liquefiable zones. We can see this structure is an example, this section. We can see this zone is consisted of underfloor tailings, which is a coarse material, coarse and unsaturated. And the blue line is the flat level. The thickness is around 50 to 60 meters. And how can perform CP2 test here? Just the CP2 can penetrate 5 meters or 10 meters. But we need more. Again, the correlation for tailings are for saturated materials. So there are no correlation for unsaturated materials. So it's not convenient, this information. We need to penetrate more than that. And so for that, to solve that, the CP2 is performed together drilling equipment in order to reach more depth and to reach the saturated region. How to perform geotechnical monitoring without workers in risky zones? In that type of structures, and we need to continue monitoring, reading piezometers, reading instruments. But the workers can stay in risky zones. So for that, the workers enter to risky zone, tied to a leaf line. This system is named leaf line spider. And so in case of a hypothetical failure, the workers can be lifted and transported to safe zone, just in case. But it was with. Here's a picture from the system. It's operating. Currently it's operating. How to interpret geotechnical laboratory results? For these structures, can you imagine there are so many structures to be decommissioned, and so we need to perform so much laboratory testing. And according to this research, the definition of the shared cell envelope, there are not so many difference between different laboratories. No? In this research, it was performed a round-robin program. The same sample of tailings was sent to some laboratories around the world, and they performed laboratory testing independently. And so the result show us the same shares in the envelope. It's good. But for the critical state line, they show different critical state line. And so this information is sensible to the preparation of the samples, the laboratory procedures. And so we need to take care when we use these results to be aware about the limitation of testing. When we make the models, the numerical models, or we perform slope stability, or when we calculate the potential of liquefaction. Well, other challenge is how to consider the interference in the project. And in this picture, we can see the TSF, the Tailings Storage Facility, close to mine waste dam and close to open pit, and a railroad. The railroad is operating, so the mine depends of the operation of the railroad. We cannot stop the operation. But to eliminate this structure can cause some disturbances to other structures. So we have to consider structures near to TSF. What important is to have licensed areas. So in this example, we can see the rainforest close to the dam. And so we don't have license to do battles here. It's so difficult. It's a process could take some years. It's not possible sometimes to get a license. Maybe we can receive a negative response. How many dams should be decommissioned in Brazil? Currently, the information is there were 59 absentees. It's a lot. 21 dams were decommissioned and 38 are in progress project or in progress. Can you imagine if anytime, anywhere, 59 dams were decommissioned at the same time? It's a big impact of the regulation, but it's happening in Brazil now. And so for this reason, there is a shortage of geotechnical engineers due to the numerous projects are in progress simultaneously. There are some local and international initiatives to train geotechnical engineers, EOR designers, third-party reviewers, RTFE, governance engineers, IT specialists are in demand, high demand in Brazil. Also, there is a shortage of technician, drilling equipment, and geotechnical laboratories available. If I want to send a sample, soil sample to a laboratory, I need to wait for some months, 4 to 6 months. So the projects are in demand at this moment. In the field, we have some challenges as well. For example, the trafficability. When you work on the tailings, you can walk because it's dry. But yes, if you excavate 2 meters, you can find the saturated material with high moisture. And the vehicles cannot traffic on there, so it's necessary to use amphibious excavator. Other challenge is how to perform the works without operators in risky zones. For that, remote control vehicles are used, and so the operators are in a safe zone, and the vehicles are at the risky zone. As logical, it's more expensive to use these type of vehicles, and so the budget is higher than if the conventional occurred. Another issue is the evaluation of uncontrolled vibration. As we know, the structure, some structures have marginal stability, and so we don't know if due to works a trigger could start, but to limit the trigger of the vibration, it's been performed some testing before the works in order to define threshold for vibration. For example, in this figure, we can see the geophone and the vehicles. And in this figure, you can see the trial width when simulate excavation, and at the same time monitoring the piezometers and geophones. And during the works, there is a monitoring of vibration. Some cases of the structure are already decommissioned. In this case, is a final removal of TSF. No, it's in progress, it's not completed yet. And the work is removal of 6.9 million cubic meters of tailings. The left side, as now, and the figure on the right is showing the final configuration. In case of partial removal, you can see the upper figure before the works, and after that, after the partial removal of tailings, and construction of the drainage system and rehabilitation. You can see here, looks like there was not a tailings dam here, but fortunately it was a successful project. In this case, it is the construction of rock-fill batteries, 14,000 cubic meters before and after that, and construction of the drainage system. Well, let's talk about backup dam. What is backup dam? Why we need to build that? We are talking about upstream tailing dam, and so some of that structures are very high risky structures with marginal stability, and in case of hypothetical dam failure, the backup dam could contain the flow of tailings. So this structure was built before to start the works here. And so in case of failure, this could protect the population against the flow of tailings. We can see here a back dam constructed with 180,000 cubic meters. The length is 300 meters and the height is 36 meters. It was constructed with concrete, so it's a new dam. And in this case, it's a barrier. This barrier was constructed with steel pipes filled with concrete in case of a hypothetical failure again. No, in case of the failure to avoid the flow to reach the population. And final considerations: the future, the completion of the decommissioning of all upstream TSF is planned to end by 2035. The trend we see is the diminution of tailings dam, so it's difficult to have a new license for tailings dam. The production of tailings by filtering will be more used. It's a new technology. The future projects of filtered tailings pipe considering a height of around 200 meters, stacking rates around 40 kilotons per day. The challenge is doing that in a tropical climate, like you are saying. Maybe it's easier to do that in Chile or Peru. The climate is dry, but in Brazil there are some difficulties to do that, especially in rainy season. It's expected to a reduction of risk by changing the disposal method. Finally, the dam decommissioning projects are complex. The classification of risks introduces more complexity because the access of workers to risk zones is not permitted. It's difficult to perform geotechnical investigation, to do the monitoring, and so on. 30 99% of upstream tailings dam were decommissioned already in Brazil. The mine waste and tailings engineering is progressively improving. Some question, could this experience be replicated in other countries? What else can be done to improve the safety of these tailings storage facilities? What is the future of geotechnical investigation in risky areas? Some question to Tim. There are some references. This final thank you for coming to attend this presentation.